All right, on the 6.9 set, we're looking at a hint being given to us where it says number 5, the tangent of A is 3/4. So if you remember, our shortcut for remembering the trig ratios is SOH, CA, TOA. That stands for the sine of an angle is equal to opposite over hypotenuse. The cosine of an angle is equal to the adjacent over hypotenuse, and the tangent of an angle is equal to opposite over adjacent. So the first question is, which angle is angle A? And you just need to pick one. It really doesn't matter. Remember that this is our 90-degree angle down here, so I'm going to pick that as angle A. So if the tangent of A, the opposite over the adjacent, is 3/4, I go to the side opposite of A and put the 3, and I go to the side adjacent to A and put the 4. If I know that's a 3 and that's a 4, I can find the missing side by using Pythagorean. 3 squared plus 4 squared is 9 plus 16, or the square root of 25. Some of you probably already recognize that triangle as the 3, 4, 5 triangle. So now that I have all the sides filled in, now I can go get the sine and cosine of A. So looking back, the sine of A is equal to the opposite over the hypotenuse. And so the sine of A is 3/5. The cosine of A is the adjacent over the hypotenuse. And so my cosine of A is 4/5. Now I'm switching gears to where the reference angle is going to be angle B instead of angle A. So now I'm going to go up here and think of the other angle as angle B. So the tangent of B is equal to opposite over adjacent. That's 4/3. The sine of B is equal to opposite over hypotenuse. That's 4/5. And the cosine of B is equal to adjacent over hypotenuse. That's 3/5. Well, that sort of matches what we did in the task yesterday. We noticed that the tangent of A and the tangent of B are just flipped, 3/4, 4/3, the inverse. We noticed that the sine of A was equal to the cosine of B, 3/5 and 3/5. And we noticed that the cosine of A is equal to the sine of B. These are some trig identities that we noticed yesterday as patterns when we did the task. We're going to go fill in the rest of these triangles and see how good you're getting at these trig ratios. So the next one gives us that the sine of B is 8/17. That's the hint that they gave us. Well, the sine function, if I look up at my trick, my shortcut, is opposite over hypotenuse of B. Well, which angle's B? I'm just going to name this A and this one B. It's literally your choice. But so if this was B, the opposite of B is 8 and the hypotenuse is 17. I now need to find the missing side using Pythagorean. So leg squared plus leg squared equals hypotenuse squared. 64 plus our unknown is equal to 289. We get that x squared is equal to 225, and that our unknown is just 15. Now that I have all sides filled in, I can now go get the rest of the trig ratios. Now, when I'm standing at side B, here's B as my reference angle, my adjacent leg is the side touching B or closest. My opposite leg is the 8, and my hypotenuse is always my hypotenuse. So I'm going over to the tangent of B. That's equal to the opposite over adjacent, or 8/15. Then the cosine of B is the adjacent over hypotenuse, or 15/17. Okay, now I'm going to go look at the reference angle A. So I'm switching gears here. This is no longer the adjacent. This is no longer the opposite. I'm now switching gears to where this is my reference angle. Now my opposite is the 15, the furthest side from A, and my adjacent is the closest side to A. So my opposite is 15. My adjacent is 8. And my hypotenuse is always my hypotenuse. So tangent of A is equal to opposite over adjacent, or 15 over 8. Oh, look, it's reverse of the tangent of B, the inverse. Okay, next is the sine of A. Standing at A, opposite over hypotenuse. And finally, cosine of A, adjacent over hypotenuse. Again, we note that the sine of A should be equal to the cosine of B, and the cosine of A should be equal to the sine of B, and they do. Pause the video and try number 7 and 8 now on your own. Okay, let's see how you did. This time if I call this A or I call this B, they're giving me a hint of the cosine of A is 12 over 13. That means my adjacent is 12 and my hypotenuse is 13. I need to find that missing leg. 12 squared plus unknown squared equals 13 squared. And so I'm getting that x equals 5. Now that I have all of these done, I can go do those side ratios. Tangent of A is equal to opposite over adjacent. How'd you do? Did you get 5 over 12? Sine of A is equal to opposite over hypotenuse. Next, I'm going to go stand at B. Tangent of B is opposite over adjacent. It's the reverse of the other tangent. Sine of B is equal to 12 over 13, opposite over hypotenuse. And cosine of B is adjacent over hypotenuse. Again, we note the same relationships. All right. Here's my A. Here's my B. The relationship they gave us is 1 over root 2 for the sine, which is opposite over hypotenuse. So the sine of B equals opposite over hypotenuse, and then we solve for the missing side. So this triangle is a 1, 1, root 2 triangle. Later, this will become important. Now I go do my trig ratios. Tangent of A So again, we're down here at this angle. Angle A, tangent is opposite over adjacent, or 1 over 1, which is just 1. Sine of A is opposite over hypotenuse, or 1 over root 2. Cosine of A, 1 over root 2. Tangent of B, 1 over 1, or just 1. Cosine of B, adjacent over hypotenuse, 1 over root 2. This is an interesting triangle, and later we're going to learn that it is a special right triangle, and there's some properties we can depend on. This part I made optional on the homework. It is best when trying to figure these out to possibly look at it in terms of some real numbers, some real examples, to see if you think that it's true. So for example, we'll call this A, we'll call this B. We'll just name this the 3, 4, 5 triangle as an example, just like our number 5 above. And let's just throw some numbers in here like 30 and 60. Why do I know those numbers work? Because this is 90 and 60 plus 30 plus 90 equals 180. I could have called this 20 and this 70. You get the drift. You're just kind of picking some numbers to see if these rules work on the left. So here it's saying that the cosine of angle A is equal to the sine of 1 over A. Well, the cosine of A, if I'm standing at this reference angle, is equal to the cosine is equal to the adjacent over hypotenuse, which would be 3/5. And then 1 over the sine of A means I'm doing opposite over adjacent, or 1 over 4/5. Is 3/5 equal to 1 divided by 4/5? And we get not the same answer. We get 5/4. 5/4 is not equal to 3/5. So number 9 is not true. If we can think of one counterexample, like this one scenario, then it's not true. Next one, tangent of B. I go stand at B and I look for opposite over adjacent. So that would be 3/4. And then we go tangent of 90 minus A. So if I go 90 minus angle A is 30, that's going to be the tangent of 60. Well, by the way, tangent of B is also 60. And so we get that the tangent of 60 is equal to the tangent of 60. So this one's a yes. All right, last but not least, tangent of A is 30, cosine of A is 30, equals sine of A, which is 30. If I multiply these out, I do get the same answer. And if I change these angles into 20 and 70, for example, and I do tangent of 20 times cosine of 20 equals the sine of 20, it still works. So test it with whatever numbers you want, but this should be a yes as well. What do you think? Those are the start of you establishing some trig identities or some rules that we can always count on with trigonometry, some patterns and some relationships that we can use. Great job if you tried those bonus problems.